Hello, and welcome to the Software Engineering Workshop at the TeensInAI AI Accelerator. My name is Alfonso Fernandez, and I'm CTO, Chief Technology Officer, but I have been a software engineer for many years. So I've built complex software, I've built teams of engineers that build complex software, I've worked for Formula One, I work for many of the game industry and telematics and retail people. So I have been involved in software engineering for over 20 years. And I'm here to show you a little bit what it takes to become a software engineer and all the different disciplines that you can get involved in order to achieve that goal. So the things that you're going to need to do is download a few things, create a couple of accounts, and that will allow you to follow the course. First, we're going to focus on Visual Studio Code. Visual Studio Code is an IDE which allows you to edit code, compile it, build it, test it. It's a user interface that allows you to do all these wonderful things with software. Then we're going to download Git. Git is a source control system. It makes sure that the source code that you write is safe, it's versioned, and you can distribute it to other people. You can do fixes to it. You can go backwards in time. You can do all sorts of clever things with it. And to follow Git, we're going to actually create a GitHub account, which extends that from your computer, which is what Git does, to the cloud, which is what GitHub does. And in that way, you can actually put that code even safer in the cloud, stored in somewhere else's servers, but also it allows you to collaborate with other developers who can access your source code and collaborate on the same code base. For this course, towards the end of the course, we're actually going to use Python. Python is one of the languages that most people are starting to learn now. It's very easy to use and it's valid for both software engineering and data science, so it's a good language to know if you're interested in AI. We are not going to go very deep into Python. We're just going to do a couple of things and find a project. But I think it's important that you download it and you get acquainted with it. And we'll go through a little bit of that towards the end of the workshop. And finally, I think it's a good idea to create a Trello account. Trello is a project management software. It allows you to create projects, put tasks in those projects, assign people to do those tasks, and move those tasks through the process of being waiting to be actioned on, in progress, done, testing, whatever stages you want to define. It's actually a very neat way of actually keeping track of particularly smaller projects that move fast and have a few people working on them, because you can see who's doing what and what task is due to be done next. So I'd really recommend that you use it. You probably find yourselves that it helps you doing the accelerator in the next couple of weeks. But let's define what software engineering is, and this is the more boring version of it. Software engineering is the systematic application of engineering approaches to the development of software. So what does that mean? Effectively, what we did, we went from being effectively bedroom programmers and everybody to themselves and trying to build software on an individual basis, to becoming a lot more systematic, a lot more process-oriented. And to do that, what we did is look at things outside software, like the scientific method, or other engineering disciplines, like, say, civil engineering, where they build buildings and bridges and things like that, and look at the processes they use to make things more predictable, more approachable, and more repeatable. And we put all those together. We obviously modified them for the software development space, and from that emerged software engineering, where a set of definitions of processes and tools and ways of writing software. But what does the software engineer entail? Well, there's a few areas or disciplines that happen within software engineering. This is just a sample of probably the key ones that you would have heard of or you want to know by the time the end of the workshop. The areas that you can get involved from the beginning, and they're very fascinating. There's many other areas to look at. But obviously the most common one, the one that everybody knows, is programming. In order to build software, you need to know how to code. And so programming entails the actual writing of software, and that means you have to understand how to write software. You need to understand how to think computationally. You need to obviously understand how to write on a particular syntax, on a language. And by language, I mean, it could be Python, it could be JavaScript, it could be Java, C#. There's plenty of them. They're very specific languages for very specific domains and problems to be solved. And they're more generic languages that you can use to write all sorts of things. There's pros and cons to using one or the other for specific things. And that's something that you learn through the lifetime of software engineering. You'll find that the best software engineers understand programming, and then the syntax is secondary. And so you can write software really in any language if you just learn the syntax for the language that you need to write the software in. Next thing that we're going to talk about is testing. So testing effectively is a way of actually testing the software that you've written. And that may also include writing code to test your code. And that's something that we will cover in the workshop. Effectively, what we're trying to do is to make the software that you write as reliable and as maintainable as possible. If you write a framework that actually tests your software as you develop it, you will realize that if you introduce a change to your code, the testing framework might very quickly say you've broken something, and you go and fix it before you actually release something to production to your customers that is broken and you didn't realize. So testing is a very important aspect of software engineering. Then we have UX and design. UX stands for user experience, and that's where we actually put the user at the center of our universe, and we make sure that whatever we build because of the user and because it solves a problem for the user. The best way to get traction with your software and make sure the users love your software and use it is address the needs of the user first. The design part then is what allows you to then make it look pretty, make it flow easily, make it just pleasing to the eye and therefore more engaging to the user. In terms of methodology, there are two major methodologies within software engineering. That is the waterfall approach, which is the old-fashioned, start designing something, and then at the very end of the process, months and months later, you'll come up with some software that may or may not be what the customer wanted, and that's why we don't use waterfall very much anymore. And then there's the agile methodology, and agile is the one that pretty much every tech company uses nowadays, and there's lots of different frameworks within agile. We'll cover a couple of those in this course, but effectively agile allows us to do much smaller pieces of work in a much more controlled way, which means that we can predict better when things are going to be done. We can predict the quality of what we're doing. We can actually make sure that we meet the deadlines that we are setting ourselves by varying different levers that we can play with through the development process. And we'll cover that all on day one, actually. Then there's infrastructure, and that's probably one of the most important parts of software engineering. Not many software engineers go deep into infrastructure. They all understand it and they all know how to build infrastructure, but there's specialists within the software engineering discipline that look after infrastructure, which is all the machinery, all the hardware, networking, virtual machines, which are virtualized computers that sit on large pieces of hardware that we can actually then deploy our software on. It's a very tricky discipline. It's a very specialized and very, very important to software engineering. And so there's the whole discipline in DevOps, which in the software engineering space, that allows us to create infrastructure as code. It allows us to actually then become fully automated deployment systems, and that's something that we all strive for in software engineering. And last but not least, source controls. As I mentioned before, Git is one of the several source control systems out there. It allows you to make sure that your source code is safe as you write it, make sure that you can actually park it for a while and move on to something else and then come back to it, and you know that it will be there. You can go back in time to whatever release or whatever version you stored, and you can store many, many versions. But the most important thing is it allows collaboration between people in the team, and those don't need to be in the same room. Especially nowadays, we're all basically working from home, and effectively what you get is a bunch of people working on the same code base without trampling over each other's feet, and that's one of the big features that source control affords us to do. So how are we going to structure the workshop? The workshop is actually over 5 days. The first day we're going to learn about agile methodologies, and this is how you organize your teams and your processes to actually deliver software. The next day we're going to look at source control, and we'll have a little bit of a practical session of an example of how you use Git. And then on day 3 we're going to look at testing. What does TDD mean? What does unit testing mean? All sorts of things that probably now don't make any sense, but they will do by the end of day 3. And on days 4 and 5 we're just going to mostly give some guidance on how to do some programming in Python, and then basically I'll set a challenge for you to try and build a little program that you can use those 2 days to perfect, and hopefully be able to show your teammates and your family to see what you've learned in the 5 weeks. So this is it for the introduction. Now I look forward to seeing you for the rest of the course. See you soon.